Hello, students. Welcome to class. Today, I will be talking about separation techniques. Separation techniques are physical methods used for the separation of mixtures. The method employed in separating a mixture is based on the differences in the physical properties of the constituents of the mixtures. Such properties include the physical states of the constituents, like solid, liquid, or gas, solubility, particle size, color, density, melting and boiling points, magnetic properties, etc. So we'll be starting with one of the separation techniques, which is separating funnel. A separating funnel is used to separate two liquids which do not mix, that is, immiscible liquids. For example, water and kerosene. When water and kerosene are mixed together, they separate out into two distinct layers. The lower, denser liquid layer is usually tapped off, leaving the upper, less dense layer in the funnel. So you take note of this. Separating funnel can also be used to separate a mixture of oil and water. Now let's look at sublimation. Sublimation is a process whereby a solid, when heated, changes directly to a gas, or a gas, when cooled, changes directly to a solid. So basically, sublimation method is used to separate a mixture of two or more solids in which one of them sublimes at a temperature below the melting point of the others. So you take note of that. Here are some examples of substance that sublime: sulfur, iodine, we have ammonium chloride, and naphthalene. Next, I'll be introducing you to a video that will give you a detailed explanation on separating funnel and chromatography.
Separating funnel. Most of the matter around us is a mixture of two or more components. Mixtures are either homogeneous or heterogeneous. Homogeneous mixtures are uniform in composition like air, and heterogeneous mixtures are not uniform in composition like oil in water. Homogeneous and heterogeneous mixtures can be separated into their components using different techniques based on the type of mixture and difference in the chemical properties of the constituents of a mixture. Separating funnel is one of the techniques that is used for separating the components of a mixture between two immiscible liquid phases. One phase is the aqueous phase and the other phase is an organic solvent. This separation is based on the difference in the densities of the liquids. The liquid with more density forms the lower layer, and the liquid with lesser density forms the upper layer. Materials required: beaker, filter funnel, separating funnel, mixture of oil and water, and stand with a clamp. Procedure: first, take the separating funnel and clamp it on the stand. Now, take a filter funnel and place it on the mouth of the separating funnel. Pour the mixture of oil and water into the separating funnel through the filter funnel. Then remove the filter funnel from the separating funnel and close the separating funnel using a lid. Now, Take the separating funnel from the stand. Invert the funnel and shake it gently and slowly open the stopcock of the funnel to release the pressure inside the funnel. Again, place the separating funnel in the stand and allow the two liquids to separate completely. We can see that oil forms the top layer and water forms the bottom layer. Now, take a beaker and place it below the separating funnel. Remove the lid on the mouth of the separating funnel. Open the stopcock of the separating funnel and pour out the lower layer of water carefully into the beaker. Close the stopcock as the oil reaches the stopcock. Take another beaker and place it below the separating funnel. Open the stopcock and now collect oil from the separating funnel. Finally, label the two components transferred into the beaker as water and oil. From this experiment, we can infer that the immiscible liquids separate out in layers depending on their densities. Since water is the denser liquid, it falls to the bottom and forms the lower layer. As oil is the lighter liquid, it forms the top layer.
Paper and thin layer chromatography, both of which are used in forensic science applications. Chromatography is a separation technique, and this will be demonstrated using food coloring. Using a pencil, draw a line at the bottom of a strip of chromatography paper. Dab a small spot of red food coloring on the pencil line and repeat with green and blue food coloring. Place this in a beaker with water, ensuring that the water level does not touch the spots. As the water is absorbed, it separates the multiple components of the food coloring. We have now created a chromatogram. The chromatography paper is called the stationary phase as it stays put. Water is called the mobile phase as it moves up the chromatography paper. Here is the key idea. A component that is more soluble in water travels a greater distance up the chromatography paper, and a less soluble component travels a shorter distance. The retention factor, or RF value, is a measure of the distance that a separated component has traveled compared to the distance that the solvent, in our example, water, has traveled. These distances can be measured using a ruler. What does the retention factor value tell you about the solubility of a separated component in the mobile phase solvent? Please pause the video to think about this and resume when you are done. A larger retention factor value means that the component is more soluble in the solvent. A smaller retention factor value means that the component is less soluble in the solvent. Thin layer chromatography, or TLC, works in exactly the same manner. Instead of chromatography paper, a glass plate with a thin layer of silica gel or any other adsorbent material is used. This thin layer of adsorbent material is the stationary phase. A suitable solvent may be used as the mobile phase. If the separated components are colorless, the dried chromatogram may be sprayed with ninhydrin, which can turn some components purple, or the chromatogram may be viewed under UV light. Ninhydrin is used to detect fingerprints from a crime scene. These chromatography methods can be used to identify and compare samples of drugs, inks, lipsticks, saliva, and explosives, just to name a few. In conclusion, paper and thin layer chromatography are used to separate components of a mixture based on their solubility. The relative solubility of the separated components can be determined by calculating their retention factor values. More soluble components have a larger retention factor value, and less soluble components have a smaller retention factor value.
Alright.